Hey everyone, today we're going to be talking about alkenes, and we're going to be looking at cis and trans, E and Z, and then doing some alkene naming and practice. So to start off, we're going to look at cis versus trans. So when you're looking at cis versus trans, cis just means directions in the same group, and trans means different directions. So for this first one, when something is cis, it has two groups or mini groups pointing in the same directions. And a lot of times, these will be in the form of the dark wedges like they're shown right here, or they can also be two dashed lines. As long as both groups are in the same direction, it is cis. Now for trans, this one has one that looks like this, and another that looks like this. It's just showing that the two groups are going in different directions. Now, one thing to note for cis versus trans, this is not used for naming. You're not going to see cis and trans in alkene names. That's what we use E or Z for. So, like I just said, E and Z are used for naming. Now we can talk a little bit more like that. So, for E, it is our trans-like configuration, which means different directions. And so, if we look at the group 2R right here, when you're looking at two or looking at a double bond, you always want to look for that longest chain. So in this case, it looks like that. And then our two sp2 carbons are these two Cs right here. Now, when we want to do E versus Z, we look at the groups attached to each side of the double bond. So you can kind of split the double bond like this, and then compare the groups. So on this side, our CH3 group is larger. And then on this side, our ethyl group is larger. So this would have the E designation for different directions of the largest groups. Now, for the cis-like, for our Z um, designation, those groups are going in the same direction. So we have the exact same molecule as before, but this time the groups are going in different directions. So we'll highlight same longest chain, except this time our largest groups are both up. So this will get the designation Z. A way I like to remember E versus Z. So Z for me is the we use like the same side or the same side. Dr. Burgos used that a lot in class. And it's kind of funny, kind of goofy, but it's an easy way to kind of think about like the Z and the same being on the same side. And then just knowing that E obviously is different if Z is the same. Now we'll get into some more complex examples of E versus Z. But first, I'm going to talk about some general notes for doing this. So E versus Z is only important or applicable when looking at double bonds or alkenes. So if you have an alkane, you're never going to have E versus Z because there's no sp2 carbons. So that's like the main thing is that sp2 carbons are what you're looking for. And when you always start, so you'll start by looking at the two sp2 carbons. And then we'll be looking for the largest group. So a lot of times you're going to see carbons and hydrogens, but you can also have bromine, chlorines, fluorines, alcohols, amines, other groups. And so you're looking at the largest group. And with that being that, you look at the atomic number. So the larger the atomic number, so I think chlorine's 17 and then fluorine's 9. The chlorine is a larger group because it's a larger atomic number, and that group would be the one that you would circle if they're on the same side. All right, now we can get into some practice. So I'm going to highlight our sp2 carbons for here and here. And something that a lot of times when Dr. Berg gives it to you in this kind of condensed bond line formula, it can be hard to tell exactly what else is on there, or if there's like a hydrogen or something like that. So always looking. So sp2 carbons want to have two bonds. So there's two ways to do, or four bonds total. There's two ways to do this. So you can either draw out everything and go like C, double bond C, and then see the groups attached, and then that's like carbons, then a hydrogen there, and carbons, carbon. Or what I like to do is just simply add on the hydrogens where you need them. Then on this right side over here, we don't have any other things to bond since this carbon right here already has four total bonds. So now we can go ahead and start looking at E versus Z. So this is pretty simple. On this left side, our purple group is much larger than our hydrogen right there. So it's going up on the left side. And then on the right, our ethyl group is the larger group. And so this one's going to be Z for the same side or same direction. Now with this, if you have something that has two of the same groups on the same side, I'll make an example really quickly. So for example, if we have something like this, while this side does have a difference, and this would be our larger group, there's no way to tell or no way to designate on the side of the hydrogens because it's the same. When groups are the same on one of the sides, there will be no E or Z, even if there's a double bond and the other side has a difference in the groups. So always be looking out for that. You need to make sure that the groups are different on both sides. So for our next example, double bond right there. And so this is one of those cases where we have a like very large atom in bromine. We have an alcohol group there. And we have some smaller carbon groups. So once again, looking for those sp2 carbons, our two red dots right here, and looking at the groups that are attached to them. So in this case, we have a bromine, which is here, and then we have a methyl group. And if you're confused by looking at these, you can also always write in your carbons right here to help show that they are there and you know what group you're looking at. So in this case, our bromine group is going to be our larger group on this side. And then on this side, our alcohol group is going to be larger. And this is because each of these atoms are the larger in atomic number, respectively for their side. So we're going to have E for different sides since the bromine is going up and the alcohol group is going down. We'll do two more examples and then move on to the actual naming and everything like that. So for this one, once again, we can circle or highlight our sp2 carbons here and here. And this one's a little more complex, and we're going to have to look a little bit deeper at exactly what we have going on. So let's start with our right side since this was a little more simpler on that side. On the right, we have CH3 and CH2, CH3. So our CH2, CH3 is going to win on the right side. But now on the left, we have a little bit more difficult thing. And so when I get to here, the initial bond that is attached is straight to that carbon there. So with those two carbons, there's no difference. So we have to go to what's bonded to that carbon. And when you do that, we like to do them in descending order, starting with the largest group. So it's going to be bromine, hydrogen, hydrogen for the top, and then alcohol, hydrogen, hydrogen for the bottom. And so we're looking for that really big first point in difference, which in this case is our bromine and oxygen. A lot of times it could be very similar all the way up until the very end, or you might even have to move on to another atom just beyond these three to see the difference. But in this case, our CH2Br group is going to take over, and this is also going to be E since they're pointing in different directions. So while you can call this trans, when we actually name it, we would never use trans in the name. Always use E or Z for alkene naming. So we'll do one more example here and then move on. So once again, highlighting those sp2 carbons is always the first place to start. We'll start with the left side. The CH3 is the larger group because it has that carbon. Carbon is much bigger than hydrogen and therefore is the group that's going to be circled, or the one that's going to have the directionality to it. Then on the right, so we kind of look and our first point of difference, so we have C bonded to, let's see, these two C's right here, this first one, are bonded to another C, an H, and an H. Same thing down here, another C, H, and an H. And then this carbon, since there's no difference in the red, we have to move on. So this carbon is bonded to F, H, and H. And then this one down here is bonded to H, H, and H. And this is what I meant by sometimes you have to move on past that first set of bonds from that original carbon. You have to move on to the second one to see where the difference is. And in this case, this fluorine group up here is going to be the one that we want since it's the larger group based on its atomic number. And so in this case, this one's going to be Z once again since it is on the same side. All right. Now we can move on to some naming basics. So a little refresher, our functional groups are OH and H2, and now alkenes. And so when I say functional group, I mean a group that modifies the parent chain. And so priority-wise, it still goes alcohol is one, amine is two, and three, alkenes. But the thing about alkenes is that even if an OH or an NH2 are present, it's always going to modify the parent chain. Alkenes will never be branches. And that's different than when you look at an amine group, because if an alcohol is present, that amine group becomes amino and is a branch. But alkenes are always part of the parent chain name. And I will show some examples of that and make it a little bit clearer in just a second. But let's say we have, let's see, something like this. Very simple. So we just have a four carbon chain. This is going to be bute, and we'll just number really quickly. Butene. And so for alkenes, we drop the A and E, add E and E. And now if we had a diene, then we would keep the A, and it would be like hepta 2,4-diene. But we'll do some examples kind of showing that a little bit later on. But if you're kind of shaky on the basics, I recommend kind of going back and watching the first two videos that really go over the functional groups and the branch naming. to help you get a stronger foundation for this type of naming because it gets a little more complicated and it adds another layer of things you have to remember to do well for this naming. This is a big part of what the naming will be like on the test for test two. So for this first one right here, we are going to start by highlighting the longest chain. So we're going to start down here and then number. So 1, 2, 3, 4, 5, 6. So same with our other naming. We always want to start with the longest chain for alkenes. But something important about alkenes is that the longest parent chain always has to include the entirety of the alkene. So both of the sp2 carbons. If you only get one of them or it's not in the longest chain, you need to relook at what you've highlighted or made as your parent chain. So naming wise for this one, it's not too bad. Just a couple of groups on there. So we're going to start with our 2, 2 bromo for that bromo group right there. And then we have 2 methyl groups. There's going to be 3, 4 dimethyl. And then our parent chain is 6, so it's going to be hex. And then our alkene starts at this 3 carbon right here. Even though it finishes on the 4 carbon right there, you want to do where it starts. You want the lowest number to be in the name. So it's going to be hex 3 ene. And so that's our base name. Now, for alkenes, we always want to look for E versus Z. So in this case, we need to look at our groups. So going up, we have a CH3, which we can add on by writing it to show it. Same right here and there. And then on the right, we have an ethyl. And then on the left, we have that branch with a bromine group on it. So if we circle our larger groups, it's going to be our ethyl, and then this group down here on the bottom. And that is going to give us Z because both those groups are pointing in the down direction. So we're going to write Z, 2 bromo, 3, 4 dimethyl hex 3 ene. And it'll be written like this with the Z and then a dash in between either the rest of the name or in this case, a number. So always make sure to include that dash. For our next example, we're going to once again highlight the longest chain that includes our alkene. So I'm going to go ahead and add on CH3 groups just to help me visually see everything, and this can help you on the test. It's up to you if you want to write them or not. And then we're going to number. So number wise, we're going to go 1, 2, 3, 4, 5, 6, 7. Now it's always important to just be careful numbering wise to make sure that you number the right direction. Because alkene, in this case, there's no other functional groups. It wants to have the lowest number. So there is a possibility that the alkene is closer to the other side. And in that case, we would want to number from the other side. But I believe this gives it the lowest overall numbering if we going from the left to the right. So now we're going to start naming. So to start off, we have 2 fluoro for our chloro group right here. And then we have 6 methyl for our methyl branch. And then our parent chain is a 7 carbon chain. So it's going to be hept. And then drop that A, add the number. In this case, there's another 3, and then ene. And so like the last one, we have to check once again for E versus Z. And so looking at it, you may not initially be able to tell that there are 100% different groups, but something I always like to do is add those hydrogens that are on here, just to help you see. So now that we can see the hydrogens on there, we can tell that there are different groups on both sides. And so on our left side, this is obviously the much larger group because the hydrogen is very small. And same on the right. This group going down is also the much larger group. And even though that group starts to go back up because it's so long, it's the one that is pointing down initially. And so in this case, this one's going to get E. But just being aware of adding in those hydrogens, or at least knowing that they are there when you have a double bond, and always checking for E versus Z. The only time that you will not have E versus Z is when you have a terminal alkene that has no other groups attached to it, like an alcohol or a bromine or anything like that. And I think we're about to do an example just like that to kind of show that a little bit more. So we'll start by doing this. And so another way you could highlight this one, if you wanted to, could be maybe say you want to go this direction, right? That yellow pathway would be wrong because it does not include the alkene. Even though it's the same length in total number of, or it's close to the same length in the number of carbons, the big difference here is that we're missing the alkene in the yellow. So erase that and then start numbering. So we're going to start by giving our alkene the lowest possible number, 3, 4, 5, 6. Pretty simple numbering for this one, nothing too crazy. And so on that 3 carbon, we have a 3-methyl group. And then our parent chain is once again hexane. But we're going to drop that A and E, add our number, even though in this case it would be redundant because it's on the 1. I like to add it anyway just to be safe, and then ene. And then just being safe, always check for E versus Z. But in this case, both of those groups on that side are both hydrogens. And even though like the E's are different, and you have some up versus down for our long chain and that other hydrogen, that left side over here for these hydrogens, they are both the same group. So this in this case, we don't have any E or Z for this one, even though there is a double bond. So if you ever see a terminal alkene, as long as there's nothing attached to this end piece right here, it probably does not have E or Z, but always check just to be safe. All right, moving on to another one. So now we have alkenes and an alcohol. So now we have 2 functional groups. So like I was saying earlier, alkenes do not become a branch no matter what. They continue to modify the parent chain along with the alcohol. So for this one, we're going to number. So we're going to go 1, 2, 3, 4, 5, 6. Then we're going to number the other way. 1, 2, 3, 4, 5, 6. So when we go from the left in our red numbering to the right, we get a 2 for our alkene, which is good, then a 4 for alcohol, which is not the greatest. But when we use our black numbering, we get a 3 for the alcohol. And like I was showing before, alcohols are still our number 1 functional group. So we want to make sure they always have the lowest number no matter what. So in this case, we're going to use the black numbering to name this. So our name is going to be, since there's no other groups, it's going to be hex 4 ene. The alkene name is going to come before the alcohol ending. So it's going to be hex 4 ene. And in this case, we're going to drop that E because for our alcohol ending, which is OL, like it always has been, we have another vowel, and 2 vowels do not go together ever in Alkene. You always want to drop those vowels. So it's going to be hex 4 ene dash 3 all. And making sure to drop that E could cost you a point on the exam, depending on how nice the graders are or how the answer key is laid out. So always being sure to check both ways, making sure that your name, all the names felt right. We had some issues on the test. People were just missing letters here and there, and some people were getting marked off for that. So just being super careful and knowing everything. Now it's time to check for E versus Z. So we have a double bond right here. We have our 2 sp2 carbons, which is great. And then, so it looks like once again, no major groups or anything on there, but we need to add in those hydrogens. So we're gonna have one going up here, and then one going down right there. So now we can easily tell that this methyl, if you want to draw it in there, you can like this. Methyl group is larger. And then on this right side, this nice carbon chain with the alcohol in there is much larger than the hydrogen. So we have a group going down and a group going up. So in this case, we're going to have E hex for E and 3 all. All right. Now we're going to move into some more complicated examples. Let's see. All right. So we're going to start numbering. So we're going to start with our branches. So we have a 2 chloro, 4 ethyl, 1 hept. And then we're looking at that first carbon. There were two sp2 carbons, but our first one is where we want to have the lowest number. So we're going to have hep 2. And once again, we're going to check for E versus Z. So add those hydrogens on there. And in this case, we don't have to worry about on our right side because we have two different groups. So on our right side, it's going to be this chlorine right there. And then on this left side is going to be our nice big old carbon group over here. So we have two groups going down. So we're going to have Z once again for the same direction. So it can be both going up, both going down. As long as they're the same, it's Z. So now we're going to get into one that has all three of our functional groups on there. But we all remember from the first test what happens when you have an alcohol and an amine together. The amine becomes a branch and takes on a slightly different name of amino instead of amine. So we're going to start numbering, having our alcohol be the lowest number since it's our primary functional group. All right. And then so since that's on the end, it's going to be 6 amino and then a 6 carbon chain. It's going to be 6 amino hex. And then right there is at 3. There's going to be 3 ene. And then we're going to drop the E once again from the ene to make it just En since we have 1 all. So the alcohol is on the 1 carbon. And technically it's redundant, but always add that 1 just to be safe, make sure that you're not missing anything like that. All right, and now we're going to look for E or Z. So like we've been doing, let's add those hydrogens on there. 3. All right, so this one's hard to tell. Our group going up. It's our larger group right there. We do that. Pretty large group, and then our group going down is our other large group. So this is going to be E, since they're going in different directions. And it can be one group up, one group down, or it can be the other side is down, the other side is up. As long as they're different, that is E. Now we're going to get into some cyclic naming for alkenes. So a lot of times you're going to see dienes like this, and we want to make sure that we have the lowest number possible for our dienes. So what we're going to do for this one is we're going to start numbering right here. 1, 2, 3, 4, 5, 6. And then we're going to start with our group. So 5 fluoro, 1 methyl, cyclo. I want to make sure you don't have any spaces in between your names, so they should all be one big one. That's something we saw in the test. Let's try to eliminate that if possible. And then in this case, we're going to have hexa. So I was mentioning earlier, when we have two alkenes in a molecule, it becomes diene. So it's going to keep the A. It's going to be hexa 1 since we start here, and that one is the first, and then our next one is the three and the four, and the three is the lower number. So 1, 3, dying. And that's it for that one. A lot of times you're not going to see E versus Z on rings just because of the type of groups that are on there being the same a lot of times. So we don't have to worry about it for this one. Now, our last one on this is another ring with some more functional groups on there. Very similar to the last one or to the other one with all the groups on there, but we want to start with our alcohol and then go 2, 3, 4, 5. So we want the alcohol at the lowest, and then we want to go to our next functional group, which is the alkene, to give it the lowest, rather than going to the amino since it becomes a branch. So this is going to be 4 amino, cyclo, pent, 2, ene, 1, all. Always making sure to drop that E when you have an alcohol. So, all right, lastly, we're going to go over one of the problem sets that um, you have. This is the group 12, which I don't believe anybody has, so we're going to go over that one. Some extra practice. So this one's tricky. So always, always look for longest chain that includes the full alkene. What I mean by that is that includes both sp2 carbons. So in this case, we're going to highlight, make sure we get the whole thing in there and go like that. We're also going to start our numbering down here. It's going to be 1, 2, 3, 4, 5, 6. And then we're going to start. So we have a methyl on the 2 and the 4. So we 2, 4, dimethyl. And then hex is the 6-carbon main chain. And then 1 ene. Technically that one's redundant, like I've been saying, but always add it just to be safe. And now also, since that alkene is on the end, like I was saying earlier, we erase that one, just put one there. We have 2 hydrogens going off like that. No E or Z, just because the groups are the same on that one side. Now on the other side, we have that methyl, which is right here, and then we have the other long chain. So that side has different groups, but both sides all have to have different groups for E or Z to be a possibility. Here we have another ring. So we're going to number a little bit on this one. So we want to make sure that everything has the lowest numbers possible while also including the full alkene. So we can't start here and then go 2 because that does not include the full alkene. We're going to go 1, 2, 3, 4, 5. And now you can check and see, we can try the 1, 2, 3, 4, 5. That 4, the black gives us 4, 5 for our group rather than a 3, 4 in the red. So we're definitely going to use the red here. So we 3, fluoro, 4, methyl, and then cyclopentene. Once again, oops, the 1 is redundant, but I like to include it personally. It is up to you. Move on to 3. So like this one right here has the alkene right there on the end like that, kind of sticking out weird. And you might want to be really tempted to go around and do the longest chain this way, but that completely misses the alkene and we don't have both sp2 carbons. So what we're going to do is go and look at it this way. And we're going to have a nice propyl group right here. So we're going to number 1, 2, 3, 4, 5, 6, 7, 8. And then we have a 2 propyl. And then the main chain is 8, so it's going to be oct, 1, ene. And once again, that alkene is terminal. And when I say terminal, terminal means the end. So if you see an alkene on the end or a terminal position, always make sure that there's no other groups. And if there are no other groups, it is going to be no E or Z. So I'm going to do another one right here, highlighting that longest chain and looking at our numbering. So we're going to go 1, 2, 3, 4, 5, 6. And try another way. 1, 2, 3, 4, 5, 6. When you have two different functional groups or other groups on there, always check the numbering to see which one is more ideal. In this case, that purple is going to be better because it gives our alcohol a 3. So we're going to have hex, 4-ene, dropping that E, so an alcohol, and 3 all. Now in this case, we want to look for those hydrogens. So we have an H going down and then an H going up. So now we want to look for our largest group. So here we have this methyl bigger than the hydrogen, and then this nice group over here is bigger. So one group's going up like this, and the other group's going down like that. So we're going to have E hex, 4-ene, 3 all. And then our last one right here is another diene. So just always be careful when numbering. You don't want to start here and then go 2, 3, 4, 5, 6. That is not the way to number alkenes. The purple number is the correct way we're going to do it right here. So it's going to go 1, 2, 3, 4, 5, 6. And like I was saying, it always has to include both sp2 carbons when you're starting the numbering. Okay, now let's name this one. So it's going to be cyclo as our parent. And then in this case, it's going to be hexa, once again, because we can drop, well, because we have that diene. So we're going to keep the A rather than dropping it. It's going to be hexa, 1, 4. We always know the lowest number, so we're going to have that 1 here, and that's 4 there. That is the start of each alkene. 1, 4, and then diene. So that's pretty much all naming-wise that we have for alkenes. We will cover alkynes on this test, and we'll have stuff about that later. But right now, if you have any questions on alkene naming, please come to office hours. Reach out in the group me, email, whatever works for you all. Good luck studying and good luck on this problem set later this week.